Hello, good evening, students. In last lecture, we have discussed about the belt drives. Types of flat belt drives. There are many types of flat belt drives. In last lecture, we have discussed about the open belt drive, second crossed or twist belt drives, third is quarter turn belt drive, in the first two types of belt drives, open and cross belt drives, the shafts are parallel to each other, but in quarter turn belt drive, shafts are perpendicular to each other. Fourth is belt with idler pulley. Fifth type of belt drive is compound belt drive. Sixth type of belt drive is stabbed or cone pulley drive. We have discussed in last lecture compound belt drive, belt with idler pulley, quarter turn belt drive, crossed or twist belt drive, and open belt drive. Now, in stabbed or cone belt pulley drives, shafts are parallel to each other, having pulleys with different diameters. Attached to each other. In Stepped or cone belt drive on the follower or driven shaft. Stepped and cone pulley are mounted. Belt transferred to the pulleys. Here the pulley 1, 2, 3 are having different diameters, and on the follower or driven shaft 4, 5, 6 pulleys have different diameters. Okay. Now power is transmitted from driven shaft to the driving shaft. Here the velocity ratios of pulley 1 and pulley 4 are is according to the diameter of the pulleys. Okay. So with the help of a stepped or cone pulley drive, we can get different velocities ratio at different velocity output at the driven or follower shaft. Now the final type of belt drive is fast and loose pulley drive. In fast and loose pulley drives, the main line shaft has a pulley of fixed diameter, and on driven shaft there are two pulleys. First pulley is known as loose pulley, and second pulley is known as fast pulley. This is the driving pulley. Okay, this is the line shaft, and this is the machine shaft. Now these are the belt drives. Now come to the next topic, velocity ratio of belt drive. Hello. Velocity ratio is the ratio between the velocity of driver and follower or driven. Okay. Let d1 is equal to the diameter of driver pulley, d2 is equal to the diameter of driven pulley, n1 is the speed of driver in rotation per minute, n2 is equal to the speed of driven in rotation per minute. Okay. Now length of the belt that passes over the driver in 1 minute equals to the pi d1 n1. Similarly, length of belt that passes over the driven in 1 minute is equal to the pi d2 n2. Since length of belt that passes over the driver in 1 minute is equal to the length of belt that passes over the driven in 1 minute. Therefore, pi d1 n1 should be equal to the pi d2 n2. Here velocity ratio n2 by n1 will be equal to the d1 by d2. Okay, if the thickness of the belt is given t, then this velocity ratio will be n2 upon n1 is equal to d1 plus t upon d2 plus t. This is the velocity ratio of belt drive. Now, velocity ratio of a compound belt drive. Consider a pulley 1 driving the pulley 2. Since the pulley 2 and 3 are keyed to the same shaft, therefore pulley 1 also drives the pulley 3, which in turn drives the pulley 4. This will be the compound belt drive. This is the compound belt drive. Here pulley 1 turns the pulley 2, and pulley 2 and 3 are mounted on the same shaft, intermediate shaft, and pulley 3 turns the pulley 4, which is a follower shaft. Okay. Let d1 is equal to diameter of pulley 1, d2 is equal to diameter of pulley 2, d3 is equal to diameter of pulley 3, d4 is equal to diameter of pulley 4. Okay, and n1 is equal to the speed of pulley 1, n2 is equal to the speed of pulley 2, n3 is equal to the speed of pulley 3, n4 is equal to the speed of pulley 4. Okay, we know that velocity ratio of pulleys 1 and 2 will be N2 upon N1 is equal to D1 upon D2, equation number 1, and velocity ratio of pulleys 3 and 4 will be N4 upon N3 is equal to D3 upon D4. Equation number 2, multiplying equations 1 and 2, N2 upon N1 into N4 upon N3 will be equal to the D1 into D3 divided by D2 into D4. Here pulley 3 and pulley 4 are on same shaft, then N3 will be is equal to the pulley 2 and 3 are on same shaft, then the speed of pulley 2 and 3 are same. So from above equation, N4 upon N1 is equal to the D1 into D3 divided by D2 into D4. A little consideration will shows that if there are 6 pulleys, then N6 upon N1 will be is equal to D1 into D3 into D5 divided by D2 into D4 into D6. So from here, speed of last driven pulley upon speed of first driver is equal to the product of diameter of drivers divided by product of diameter of drivens. This is the speed ratio for the compound belt drive. Now next topic is slip of belt. We calculated the velocity ratio in the previous topic by assuming that belt and shafts has a firm frictional grip between the belts and the shafts, but sometimes the frictional grip becomes insufficient. This may cause some forward motion of the driver without carrying the belt with it. This may also cause some forward motion of the belt without carrying the driven pulley with it. This is called slip of the belt, and it is generally expressed as a percentage. The result of the belt slipping is to reduce the velocity ratio of the system. This slip result of the belt slipping is to reduce the velocity ratio of system. As the slipping of the belt is a common phenomenon, thus the belt should never be used where a definite velocity ratio is importance. Okay. Now let S1 is equal to the S1% is equal to the slip between the driver and belt. S2% is equal to the slip between the belt and follower. Okay. Then velocity of belt passing over the driver per second V is equal to the pi d1 n1 by 60 minus pi d1 n1 by 60 into s1 upon 100. This is the slip velocity due to the slip. So the actual velocity will be is equal to the pi d1 n1 upon 60 1 minus s1 upon 100. Now the velocity of belt passing over the follower per second pi d2 n2 by 60 now will be equal to the v minus v into s2 by 100. The velocity transfer belt passing over the driver v is pi d1 n by n1 upon 60 1 minus s1 upon 100 1 minus s2 upon 100. Now pi d2 n2 by 60 will be equal to pi d1 n1 upon 60 within bracket 1 minus s1 upon 100 minus s2 upon 100 plus s1 s2 by 100. Here s1 s2 is very small, then s1 upon s2 upon 100 can be s1 into s2 upon 100 can be neglected. Now from here n2 upon n1 is equal to the d1 by d2 1 minus s1 upon 100 minus s2 upon 100 or n2 upon n1 is equal to the d1 upon d2 1 minus s1 plus s2 by 100 or n2 upon n1 is equal to d1 by d2 1 minus s upon 100. Here s is the total percentage of slip is equal to the s1 plus s2. If the thickness of the belt is given, then the velocity ratio will be n2 upon n1 is equal to the d1 plus t upon d2 plus t 1 minus s upon 100. Okay, this will be the velocity ratio due to the slip of the belt. Now solving a problem on this topic. An engine running at 150 rpm drives a line shaft by means of a belt. The engine pulleys is 750 mm diameter and the pulley on the line shaft being 450 mm. A 900 mm diameter pulley on the line shaft drives a 150 mm diameter pulley keyed to a dynamo shaft. Find the speed of the dynamo shaft. When first there is no slip and second there is a slip of 2% at each drive. An engine running at 150 rpm drives a line shaft by means of a belt The engine pulley is 750 mm diameter and the pulleys on the line shaft being 450 mm. A 900 mm diameter pulley on the line shaft drives a 150 mm diameter pulley keyed to a dynamo shaft. Find the speed of the dynamo shaft when there is no slip. And second, there is a slip of 2% at each drive. Uh, Here this is a compound belt drive. Okay, this is a compound belt drive. Suppose engine shaft is at 1, pulley 1. The diameter of this pulley is given 750 mm. Engine shaft. Second line shaft, pulley 2, has a diameter of 450 mm. Pulley 3, which is keyed on the same shaft, has a 900 mm diameter, and dynamo shaft has 150 mm diameter pulley. Okay. Now, given N1 is equal to the 150 rpm, D1 is equal to 750 mm, D2 diameter of pulley 2 is 450 mm, diameter of pulley 3 is 900 mm, diameter of pulley 4 is 150 mm. Okay, let N4 is equal to the speed of dynamo shaft. First, when there is no slip, we know that N4 upon N1 is equal to D1 into D3 upon D2 into D4. N1 is given 150, diameter of pulley 1 is 750 mm, diameter of pulley 3 is 900 mm, diameter of pulley 2 is 450 mm, and diameter of pulley 4 is 150 mm. Now from here N1 upon 150 will be equal to the 10, or N4 is equal to the 1500 rotation per minute. Second, when there is a slip of 2% at each drive. In that case, N4 upon N1 is equal to the D1 into D2, sorry, D3 divided by D2 into D4 multiplied by 1 minus S1 upon 100 into 1 minus S2 upon 100. Because slip is between the gear 1 and 2, the pulley 1 and 2 and pulley 3 and 4. Now N4 upon 150 will be equal to the 750 into 900 divided by 450 into 150, 1 minus 2 upon 100 into 1 minus 2 upon 100. This is equal to 9.6. So N4 will be equal to the 150 into 9.6, or N4 is 1440 rotation per minute. This is the speed of the dynamo shaft due to the pulley slip. In next lecture we will discuss about the creep of the shaft, creep of belt, and length of an open belt drive and length of cross belt drive. Okay, in next lecture we will discuss about these topics and power transmitted by a belt. Okay, thank you very much.